All right, guys. Hi, welcome back from the ad break. So we've been looking at a whole lot of things, right? But for now, the main thing that we actually looked at is drawing two graphs that satisfy two equations, right? Two linear equations. And we said there's only going to be one point that satisfies those two equations. But remember our big question, which I'm just going to show you now. So our big question is, how can we then determine the point of intersection of two linear equations algebraically? And that we are going to do with method 1, and that's the elimination method, and method 2, which is the substitution method, which we're going to do at a later stage. So the elimination method, this is the method for solving a pair of simultaneous equations that reduces one equation to one that has only one variable. Because remember, if I give you 2x plus 5 equals to 3, this you can definitely do. But if I then make it plus 5y, it then becomes a different story, because now it means you must know one variable. So elimination is such that we either get rid of the variable of x, we solve the y, and then substitute later, or we get rid of the y, solve the x, and then work it out later. The steps to do this, the very first step will be, whenever necessary, you need to first rearrange both equations so that the x terms are first, followed by the y terms, and the equal sign, then our constant. Please try to do it in this order most of the time, right? So it must be maybe ax, a is a constant value, plus by, which is a constant value, is equals to c, which is another constant value there, right? As you saw with the previous examples, maybe 2x plus 5y equals to 8, like this. So you always start with the x, follow with the y, the equal sign, and then my constant on the other side of the equal sign. If an equation appears to have no constant term, then you know it means that my constant term is always going to be 0. The second step is you need to multiply one or both the equations by a constant that will allow you to then either subtract or cancel either the x or the y value, so that you are left with only one variable. But how do you cancel that? You use addition or subtraction. So it's always maybe the first equation minus the second one, or the second one minus the first one, or adding both of them so that one variable cancels, right? And then the third step will be you add or subtract the equations. Why do you do that? You want to only remain with one variable, right? You want to remain with one variable so that it is easy for you to then solve this. You solve the remaining variable, which is that one variable I've just spoken about. At the end, for you to find the other variable, you will substitute the result you got in step 4 into one of the original equations and then solve. But I know all of this is just language, right? Let's look at a typical example of what we need to do. So you can already see 3x, 4x. I can't really cancel it, right? If I subtract, I will be left with 1x. Either a negative or a positive, it doesn't really matter. If I add, I will get a 7. So I'm not going to consider cancelling x. Let's look at y. Minus 2y plus 2y. If I subtract them, it will give me minus 4. So I cannot subtract. But if I add them, it will give me 0. So it means I must then first start by cancelling the y, solving the x, and then going to solve the y after. So I will firstly call this equation 1, and I will call this equation number 2. Most of the time, that's really easy for you to do, because you can just say equation 1 plus equation 2, because it's a language, guys. You need to communicate with me and tell me what you are doing, because I don't just want to see things, right? So 3x plus 4x will give me 7x, minus 2y plus 2y will be 0, equals to the 8 plus the 6 will then be 14. Divide both sides by x, I get, by 7 I mean, sorry, I get x is equals to 2. Now remember my last step, right? Which is step 5. You substitute the answer, which is what I just got now. I got my x as equals to 2. You substitute that into one of the original equations. I'm going to do it with both of them so that you can see what I mean when I say into either one, to then solve the other variable. So if I substitute it, 3x minus 2y equal to 8, so 3x minus 2y equals to 8. If I substitute my x as equals to 2, I will get 3 into 2 minus 2y equal to 8. This is 6 here, so it will be 6 minus 2y equal 8, minus 2y equal to negative 2, positive 2 I mean, because it's going to be 8 minus 6. Then my y will be equals to negative 1, right? So it means my ordered pair for now will then be the 2 and the minus 1 there. Remember what we did when we were drawing the two graphs. That's where these points were intersecting. But let's look at, if I use the other equation now, which is 4x plus 2y equal to 6, 4x plus 2y equals 6, it will be 4 multiplied by the 2 plus the 2y equal to 6. 4 multiplied by 2 is 8, so this will be 2y is equals to 6 minus 8, which is 2y equals to negative 2. Then my y will be equals to negative 1. So even with this, it will be 2 and minus 1 as an ordered pair. So this is how we can then use this. But now let's look at another question that involves this, right? Where you cannot just cancel from the get-go. X and 2x, you can't cancel them, right? Because they are not like terms. Not like terms, they don't have the same value. 3y and y, you also cannot cancel them. Why? Because they don't have the same value. If I add the x and the 2x, I will get 3x. If I subtract them, I will either get a plus or a minus x, so it means I cannot do that. If I go to the y and I add them, it will give me 2y. If I subtract them, it will give me 4y, right? Still, I still have the two variables, so I must do what? I must go back to my steps. Let me show you. Remember the second step. I said multiply one or both equations by a constant that will allow you to then, cancel out one variable. So what does that mean? I can just say I'm choosing 3. I'm choosing x, to cancel x first and solve for y. To do that, it means this x here must be 2x. That will remain 2x. So it means I must multiply this by 2 in order to make that 2x. But remember, mathematically, what you do on one side, you must do with everything else to maintain the balance. So this will now be 2x plus 6y equal to 24. So I multiplied it with that, and with this. And then this will be 2x minus y equals to 5, right? And then remember I said just try to label them. Equation 1, equation 2, Then I will just say equation 1 minus equation 2. So it will be equation 1 minus equation number 2. So to do that, 2x minus 2x will be 0. 6y minus y will give me 7y equals to 24 minus the 5 there will then give me 19. So let me quickly verify that I've done the right thing here. It will be 6y minus that, which is definitely 7y. Then the 24 minus that will give me the 19 there. So it means now I am at 7y equals to 19. Then y will be equals to 19 over 7, right? Why am I getting a fraction? Oh, yes, so you do get a fraction at times, because then I was just quickly looking at whether there's something we did not do right. So that is 2, that is 6. 12 by 2 is definitely 24. You subtract, you definitely get this, all right? So I can choose either of the two original equations, right? So I will take the first one, which is x plus, I think it was 3y equals to 12. You substitute that y there, so it's x plus 3 into the 19 over 7 equals to 12, and then you solve, right? So x will be equals to, all right, so if we press this in our calculator, it will therefore be 3 open bracket into the 19 divided by 7, which will give me that. So it will be 12 minus that answer, which will give me 27 over 7. So this will be 27 over 7. Now, so my ordered pair will be the 19 over 7, but that's the y, so the x will be 27 over 7. Now, the last example that we're looking at, this is easy as well. Firstly, you just label this as 1, label that as 2. Then you will just say 1 plus the 2. If you add them, you will have 3x equals to 12. Then my x is equals to 4. And then to find the y, it will be 4 minus y equals to 3, which will therefore make negative y is equals to minus 1, then my y will be equals to positive 1. And therefore, the ordered pair will then be the 4 and 1 as the answer. Remember, always label them, make it a point that one variable, if you add or subtract, can be cancelled, and then solve the other one, and always write it as an ordered pair at the end. All right, guys, that's it from me. I hope you've been enjoying and you are still having so much fun with me. But for now, I want us to stretch a bit, just drink some water so that you can be a bit refreshed. And when I come back, we'll then look at some more work that we need to do together. Please stay tuned.